Welcome, dear listener, to a gentle journey through one of the most important topics of our time. Tonight, we're going to explore global warming, not with alarm or urgency, but with quiet understanding, with the steady patience that comes from looking at something clearly. This is 99 Facts About Global Warming to Help You Sleep. Before we begin, I invite you to settle into comfort. Perhaps you'd like to press the like button and subscribe for more peaceful explorations like this one. But there's no rush. Everything can wait until tomorrow. Let your body sink into the surface beneath you. Release any tension you're holding. Allow your breathing to find its natural rhythm, steady and calm. Tonight, we're not here to solve anything or to carry worry. We're simply here to understand, to learn, to see this challenge with clear eyes and a peaceful mind. Global warming is a complex topic, woven through with science and systems, causes and effects that span decades and centuries. But understanding doesn't require anxiety. Knowledge can be calm. Awareness can be peaceful. And tonight, we'll explore this topic as we might explore a landscape. Observing, noticing, letting information settle gently. So take one more deep breath. Let it out slowly. And let us begin this quiet journey through the warming world. Global warming refers to the long-term heating of Earth's climate system. Since the late 1800s, the planet's average surface temperature has risen by approximately 1.1 degrees Celsius. That might seem like a small number, but in the context of the entire planet, even a single degree represents an enormous amount of accumulated heat energy, affecting weather patterns, ocean currents, and ecosystems around the world. What's important to understand is that Earth's climate has always changed over geological time. Ice ages have come and gone. Temperatures have risen and fallen. But what makes current warming different is the pace. Natural climate changes typically occur over thousands or tens of thousands of years. The warming we're experiencing now is happening over decades, a speed unprecedented in Earth's recent geological history. Consider the greenhouse effect, which is actually a natural and necessary phenomenon. Earth's atmosphere contains gases, including carbon dioxide, methane, and water vapor, that trap some of the sun's heat, keeping our planet warm enough for life. Without this natural greenhouse effect, Earth would be frozen, with an average temperature far below zero. The greenhouse effect itself isn't the problem. The problem is that we're intensifying it. Here's something about carbon dioxide that's worth understanding. This molecule, made of one carbon atom bonded to two oxygen atoms, has a unique property. It allows visible light from the sun to pass through the atmosphere, but absorbs infrared radiation, heat energy, that Earth emits back toward space. When carbon dioxide concentrations increase in the atmosphere, more heat gets trapped and the planet warms. In another part of this story, we need to understand where extra carbon dioxide comes from. For millions of years, carbon was stored underground in the form of coal, oil, and natural gas. Ancient plants and organisms compressed over geological time. When we burn these fossil fuels for energy, we release that stored carbon back into the atmosphere as carbon dioxide. We're taking carbon that was locked away and putting it back into circulation. What's remarkable about the amount of carbon dioxide in our atmosphere is how precisely we can measure it. scientists have been taking direct atmospheric measurements at Mauna Loa Observatory in Hawaii since 1958. These measurements show a clear upward trend. Before the Industrial Revolution, atmospheric carbon dioxide was around 280 parts per million. Today, it exceeds 420 parts per million, a level not seen on Earth for millions of years. The increase isn't steady, but shows an annual rhythm. Each year, carbon dioxide levels rise during Northern Hemisphere winter when plants are dormant, then fall during summer when plants are actively photosynthesizing and absorbing carbon dioxide. This creates a sawtooth pattern on graphs, up and down with the seasons, but with each peak and valley higher than the year before. The planet is breathing, and we can see its rhythm in the data. Consider ice cores from Antarctica and Greenland, which provide a window into Earth's climate history. By drilling deep into ancient ice and analyzing air bubbles trapped within, scientists can determine atmospheric composition going back hundreds of thousands of years. These cores show that carbon dioxide and temperature have moved together throughout Earth's history. When one rises, so does the other, revealing the intimate connection between atmospheric composition and planetary temperature. Here's something about feedback loops that makes climate science complex. Some warming effects amplify themselves. When ice melts, it reveals darker water or land beneath. This darker surface absorbs more sunlight instead of reflecting it back to space, causing more warming, which melts more ice. This self-reinforcing cycle is called a positive feedback loop, though there's nothing positive about it. The term just means it amplifies the original change. What's fascinating about permafrost is how much carbon it holds. Permanently frozen ground in Arctic regions has trapped organic matter, dead plants and animals for thousands of years. As the Arctic warms and permafrost thaws, microbes can finally decompose this organic matter, releasing carbon dioxide and methane. This represents a massive store of carbon that could be released relatively quickly as warming continues, creating another feedback loop. In the oceans, something critical is happening. Oceans absorb about 30% of the carbon dioxide we emit. This might seem helpful, and in one sense, it is. It keeps that carbon dioxide out of the atmosphere temporarily. But dissolved carbon dioxide makes seawater more acidic, creating challenges for marine life, especially creatures with shells or skeletons made of calcium carbonate, which dissolves more easily in acidic water. Consider coral reefs, often called rainforests of the sea. These ecosystems support roughly a quarter of all marine species, despite covering less than 1% of the ocean floor. Corals are sensitive to temperature changes. When water gets too warm, corals expel the symbiotic algae that give them color and help them survive, a process called bleaching. Bleached corals can recover if conditions improve, but severe or prolonged bleaching events can kill them. Warming oceans are causing more frequent and severe bleaching events worldwide. Here's something about sea level rise that unfolds slowly but inexorably. As water warms, it expands. Thermal expansion. Warmer oceans take up more space than cooler ones. Additionally, melting ice sheets and glaciers add water to the oceans. Together, these processes have raised global sea levels by about 20 centimeters since the late 1800s. This might not sound dramatic, but it affects coastal communities, increases flooding and makes storm surges more damaging. What's remarkable about the Greenland ice sheet is its immense scale. This sheet contains enough ice that if it melted completely, global sea levels would rise by over 7 meters. Complete melting would take centuries, but the ice sheet is losing mass faster now than in previous decades. Satellite measurements show hundreds of billions of tons of ice disappearing from Greenland each year, flowing as meltwater into the North Atlantic. In Antarctica, something even larger is happening more slowly. The Antarctic ice sheet contains about 90% of Earth's ice. Its complete melting would raise sea levels by nearly 60 meters, though this would take thousands of years. More immediately concerning are ice shelves, floating extensions of ice sheets that act as buttresses, holding back glacial ice on land. As these shelves thin and break apart, glaciers behind them can flow more quickly into the ocean. Consider how weather patterns are changing. A warmer atmosphere can hold more moisture, about 7% more for each degree Celsius of warming. This means storms can carry more water, making heavy rainfall events more intense. At the same time, warmer temperatures increase evaporation, intensifying droughts in some regions. The planet is experiencing both floods and droughts with greater frequency and severity. Here's something about hurricanes and global warming. While the relationship is complex, scientists have found that warmer ocean temperatures provide more energy for tropical cyclones. This doesn't necessarily mean more hurricanes, but it likely means stronger ones, with higher wind speeds and heavier rainfall. The most intense storms are becoming more common as oceans warm. What's fascinating about jet streams is how they guide weather patterns. These fast-moving air currents high in the atmosphere help steer storms and separate cold polar air from warmer air to the south. Some research suggests that Arctic warming, which is happening faster than warming elsewhere, may be affecting jet stream behavior, potentially causing it to meander more, which can lock weather patterns in place. This could mean longer heat waves, longer cold spells, longer droughts, and longer rainy periods. In forests around the world, warming creates stress. Trees adapted to certain temperature and moisture conditions find themselves in environments that no longer match their needs. Some forests are migrating, slowly over generations, toward cooler regions or higher elevations. But trees can't move quickly, and many face increasing stress from heat, drought, and changing pest patterns. Bark beetles, for instance, are surviving winters in regions where cold used to kill them, allowing them to devastate forests. Consider the seasons themselves, which are shifting. Spring arrives earlier in many places, trees leafing out sooner, birds nesting earlier, flowers blooming ahead of historical schedules. Fall extends longer. Winter contracts. These shifts might seem pleasant. Longer growing seasons, earlier spring, but they can disrupt ecological relationships that developed over millennia. When flowers bloom before their pollinators emerge, or when birds arrive after peak insect abundance, the intricate web of ecosystem timing frays. Here's something about alpine glaciers that serves as a visible indicator of warming. Mountain glaciers around the world are retreating. Photographs comparing glaciers in places like Glacier National Park, the Alps, or the Himalayas show dramatic shrinkage over decades. These glaciers provide water for millions of people downstream, feeding rivers during dry seasons. As glaciers diminish, this reliable water source becomes less reliable. What's remarkable about the Earth's energy imbalance is how we can measure it. More energy from the Sun is entering Earth's system than is escaping back to space. This trapped energy, roughly 1 watt per square meter averaged across the planet, might sound tiny, but across Earth's entire surface, it amounts to the energy equivalent of hundreds of thousands of nuclear power plants running continuously. This energy goes into warming air, land, and especially oceans. In the soil beneath our feet, invisible changes are occurring. Soil organisms, bacteria, fungi, tiny invertebrates, are affected by temperature. Warmer soil often means faster decomposition of organic matter, which releases carbon dioxide. In some ecosystems, this creates yet another feedback loop. Warming releases carbon from soil, which causes more warming, which releases more carbon. The ground itself is part of the carbon cycle. Consider how global warming affects human health in multiple ways. Heat waves directly cause heat-related illnesses and deaths, particularly among elderly and vulnerable populations. Warmer temperatures expand the range of disease-carrying mosquitoes, potentially spreading diseases like malaria and dengue fever into new regions. Air quality suffers during heat waves. Changing precipitation patterns affect food and water security. The impacts on human well-being are diverse and interconnected. Here's something about agriculture and food security. Farming depends on predictable climate patterns: when to plant, when rains come, how long the growing season lasts. As these patterns shift, farmers must adapt. Some regions may benefit from longer growing seasons or increased rainfall, while others face drought, heat stress, or extreme weather that damages crops. Coffee, chocolate, wine grapes, and staple grains all face challenges from changing climate conditions. What's fascinating about carbon sinks is how they naturally remove carbon dioxide from the atmosphere. Forests, oceans, and soil all absorb and store carbon. Roughly half of the carbon dioxide humans emit each year is absorbed by these natural sinks. Without them, atmospheric carbon dioxide would be rising even faster. Protecting and expanding these sinks through forest conservation, reforestation, and soil management is part of addressing global warming. In the Arctic, warming is occurring at more than twice the global average rate, a phenomenon called Arctic amplification. This happens partly because of the ice albedo feedback loop mentioned earlier. As white, reflective ice and snow melt, they reveal darker ocean and land that absorb more sunlight. The Arctic is transforming rapidly, with sea ice extent declining, permafrost thawing, and ecosystems shifting in ways that reverberate globally. Consider the North Atlantic Ocean and its deep circulation patterns. Cold, salty water in the North Atlantic is dense and sinks, driving ocean currents that distribute heat around the globe. Some evidence suggests this circulation is weakening as Greenland ice melts and adds fresh water to the North Atlantic, making surface water less dense and less likely to sink. A significant weakening could alter weather patterns across the Northern Hemisphere. Here's something about renewable energy that represents hope and possibility. Solar panels, wind turbines, and other renewable energy technologies don't emit carbon dioxide during operation. As these technologies have improved and scaled up, they've become increasingly cost competitive with fossil fuels. In many places, new renewable energy is now cheaper than new fossil fuel power plants. This economic shift makes clean energy transitions more feasible. What's remarkable about photosynthesis is that it's been removing carbon dioxide from the atmosphere for billions of years. Plants, algae, and certain bacteria use sunlight to convert carbon dioxide and water into sugars, releasing oxygen as a byproduct. This process built Earth's oxygen-rich atmosphere and continues to absorb enormous amounts of carbon dioxide annually. Supporting plant life through forest protection, restoration, and sustainable agriculture enhances this natural carbon removal. In cities around the world, the urban heat island effect intensifies warming locally. Dark pavement and buildings absorb heat. Lack of vegetation means less cooling from evapotranspiration. Cities can be several degrees warmer than surrounding rural areas, making heat waves more dangerous for urban populations. Green roofs, urban trees, and reflective surfaces can help mitigate this effect. Consider the Paris Agreement, an international accord reached in 2015, where nations committed to limiting global warming to well below 2 degrees Celsius above pre-industrial levels, with efforts to limit it to 1.5 degrees. This agreement represents global recognition of the challenge and commitment to action. Though the pledges made so far are not yet sufficient to meet these temperature goals, the agreement is reviewed regularly with opportunities to strengthen commitments. Here's something about electric vehicles that illustrates technological transition. Transportation accounts for a significant portion of global carbon dioxide emissions. Electric vehicles, powered by electricity rather than gasoline or diesel, produce zero direct emissions. As electricity grids incorporate more renewable energy, the carbon footprint of electric vehicles decreases further. Multiple countries have announced plans to phase out sales of new gasoline and diesel vehicles over the coming decades. What's fascinating about energy efficiency is how much it can reduce emissions without requiring major sacrifices. Better insulation in buildings, more efficient appliances, LED lighting, improved industrial processes. These changes reduce energy consumption while maintaining comfort and productivity. Sometimes called the first fuel, energy efficiency is often the most cost-effective way to reduce emissions. In nature, species are responding to warming by shifting their ranges. Animals and plants are moving toward cooler regions, toward the poles and up mountains. Some can adapt or migrate successfully. Others, particularly those with limited mobility or highly specific habitat requirements, struggle. Polar bears, dependent on sea ice to hunt seals, face diminishing habitat. Pikas, small mountain mammals adapted to cold, have nowhere cooler to go when they're already at mountaintops. Consider phenology, the study of cyclical biological events. Warming affects the timing of migrations, hibernation, flowering, and breeding across countless species. When these timing shifts aren't synchronized, when a predator arrives before its prey, or a plant flowers before its pollinator emerges, ecological relationships can break down. These mismatches, called phenological asynchrony, ripple through ecosystems in complex ways. Here's something about methane, another important greenhouse gas. Methane is much more effective than carbon dioxide at trapping heat, though it doesn't persist in the atmosphere as long. Major methane sources include agriculture, particularly rice paddies and livestock, natural gas production and distribution, and decomposition in landfills and wetlands. Reducing methane emissions can have relatively quick climate benefits because of its shorter atmospheric lifetime. What's remarkable about carbon capture technology is its potential to remove carbon dioxide directly from the atmosphere or from power plant emissions before they reach the atmosphere. These technologies are still developing and not yet deployed at the scale needed to significantly impact atmospheric carbon dioxide. However, some pilot projects are operating, and research continues into making carbon capture more efficient and cost-effective. In agriculture, practices like regenerative farming, cover cropping, and reduced tillage can increase carbon storage in soil. Healthy soil, rich in organic matter, acts as a carbon sink while also being more productive, retaining water better and resisting erosion. These practices represent a way to address climate change while improving agricultural resilience and productivity. Consider how individual actions aggregate into larger impacts. While systemic change is necessary to address global warming, individual choices about transportation, energy use, diet, and consumption collectively matter. When multiplied across millions or billions of people, personal choices shape markets, drive innovation, and create political will for larger policy changes. Small actions are not meaningless when taken together. Here's something about climate models, which are sophisticated computer simulations that help scientists project future climate conditions. These models incorporate physics, chemistry, and biology to simulate how Earth's climate system responds to different amounts of greenhouse gases. While no model is perfect, multiple models developed by different groups consistently project continued warming if greenhouse gas emissions continue. The models differ in details but agree on the fundamental trajectory. What's fascinating about tipping points is how they represent thresholds beyond which changes become self-sustaining and difficult to reverse. The collapse of major ice sheets, the dieback of the Amazon rainforest, the shutdown of ocean circulation patterns. These are potential tipping points that could trigger rapid, dramatic changes. Scientists work to identify where these thresholds might lie and how close current warming brings us to them. In ecosystems worldwide, biodiversity loss and climate change interact in troubling ways. Ecosystems with greater biodiversity, more variety of species, tend to be more resilient to climate stress. But climate change itself drives biodiversity loss by making conditions unsuitable for some species. Protecting biodiversity and addressing climate change are interconnected challenges that require integrated solutions. Consider water resources and how climate change affects them. Changes in precipitation patterns, earlier snowmelt, and glacier retreat all impact water availability. Some regions face increasing drought, while others experience more flooding. Water management, infrastructure, reservoirs, irrigation systems, flood control was designed for historical climate patterns and may need adaptation for new patterns. Water security is increasingly recognized as a climate issue. Here's something about forests and their crucial role in the carbon cycle. Forests store enormous amounts of carbon in trees, roots, and soil. Deforestation releases this stored carbon while eliminating trees that would continue absorbing carbon dioxide. Forest conservation and reforestation are among the most important natural climate solutions available. Protecting existing forests is particularly critical, as mature forests store far more carbon than young ones. What's remarkable about the speed of renewable energy growth is how rapidly the transition is already happening. Global solar and wind capacity has increased dramatically over the past decade. In many markets, renewable energy is now the cheapest option for new electricity generation. This economic competitiveness, driven by technological improvement and scaling up of production, is accelerating the transition away from fossil fuels. In policy discussions around the world, carbon pricing is often mentioned as a tool to address climate change by putting a price on carbon emissions, either through a carbon tax or cap-and-trade system. These policies aim to make activities that emit greenhouse gases more expensive, creating economic incentives to reduce emissions and invest in cleaner alternatives. Many regions have implemented some form of carbon pricing, with varying degrees of ambition. Consider the concept of climate justice, which recognizes that climate change affects people unequally. Those who have contributed least to the problem, often people in developing countries, frequently face the worst impacts. Small island nations that have emitted minimal greenhouse gases face existential threats from sea level rise. Climate justice frameworks call for equitable solutions that address these disparities. Here's something about public awareness and concern about climate change. Surveys show that understanding and concern about global warming have increased significantly over the past decade, particularly among younger generations. This growing awareness is translating into political pressure for action, with climate change becoming a higher priority in elections and policy decisions in many countries. What's fascinating about Earth's resilience is its capacity to respond to changes, though there are limits. The planet has self-regulating mechanisms, vegetation growing and absorbing more carbon dioxide, clouds reflecting sunlight, ocean absorption. But these mechanisms work on certain timescales and have constraints. Understanding both Earth's resilience and its limits is crucial for navigating the changes ahead. In cities and communities worldwide, adaptation efforts are underway. Coastal cities are building seawalls and improving drainage systems. Some are creating cooling centers for heat waves. Water systems are being designed for changing precipitation patterns. Building codes are being updated for more extreme weather. Adaptation doesn't prevent climate change, but it helps communities cope with changes that are already happening and those still to come. Consider how this moment in human history is unique. For the first time, we have global scientific understanding of how our actions affect the planet's climate. We have technologies that can provide energy without warming the planet. We have international agreements and growing political will. The challenge is implementation, translating knowledge and capability into action at the scale and speed required. Here's something about hope and human capacity for solving problems. Humanity has faced and overcome enormous challenges before. The hole in the ozone layer, caused by chemicals called CFCs, was addressed through international cooperation and regulation. Air and water pollution in many developed countries improved dramatically through environmental policies. These successes show that when humans understand a problem and commit to solutions, significant progress is possible. What's remarkable about young people and climate activism is the energy and clarity they bring to the issue. Youth climate movements around the world are demanding action from political and business leaders, arguing that their generation will inherit the consequences of decisions made today. This intergenerational perspective, looking ahead decades and centuries, brings urgency and moral clarity to climate discussions. In the business world, growing numbers of companies are setting ambitious emissions reduction targets, driven by a combination of pressure from customers and investors, recognition of climate risks to their operations, and opportunities in clean technology markets. Some are committing to net zero emissions by mid-century. Whether these commitments translate to sufficient action remains to be seen, but the direction of travel is changing. Consider the role of innovation in addressing climate change. Beyond renewable energy, innovations in battery storage, green hydrogen, sustainable materials, low-carbon manufacturing, and carbon removal technologies all offer potential solutions. Research and development, supported by both public funding and private investment, continues to expand the toolkit of climate solutions. Here's something about dietary choices and their climate impact. Food production, particularly meat and dairy from ruminant animals like cattle, contributes significantly to greenhouse gas emissions. Shifting toward diets with more plant-based foods and less meat can reduce individual carbon footprints meaningfully. This doesn't require complete elimination of animal products, but rather moderation and awareness of the choices that carry higher climate costs. What's fascinating about the interconnection of environmental issues is how addressing climate change often brings co-benefits. Renewable energy reduces air pollution. Protecting forests preserves biodiversity. Sustainable agriculture improves soil health. Public transportation reduces both emissions and traffic congestion. Solutions to climate change often improve quality of life in multiple ways beyond just reducing warming. In the realm of international cooperation, climate change has become a central issue in diplomacy and global governance. Countries meet regularly through the United Nations Framework Convention on Climate Change to negotiate agreements and share progress. Climate considerations now factor into trade agreements, development aid, and security planning. The challenge of climate change is fostering new forms of global cooperation. Consider how art, culture, and storytelling play roles in climate action. Films, books, music, and visual art help people understand and emotionally connect with climate issues. Stories make abstract data personal. Art inspires and motivates. Cultural shifts in how we think about progress, consumption, and our relationship with nature are part of addressing climate change alongside policy and technology. Here's something about the concept of net zero emissions. Reaching net zero means balancing the greenhouse gases emitted with those removed from the atmosphere, resulting in no net addition to atmospheric greenhouse gas concentrations. Many countries and organizations have set net zero targets for mid-century. Achieving this requires both dramatically reducing emissions and enhancing natural and technological carbon removal. What's remarkable is that the solutions to climate change already exist. We have renewable energy technologies, energy efficiency measures, sustainable agriculture practices, and forest conservation strategies. The challenge isn't discovering new solutions from scratch, but implementing, scaling, and improving existing solutions while accelerating innovation for areas that still need better options. The tools are available. The question is whether we'll use them quickly enough. And so, we've traveled through 99 facts about global warming, through science and impacts, challenges and solutions, the complexity of Earth's systems and the possibilities for human response. This issue, vast and multifaceted, ultimately comes down to understanding what's happening and choosing how to respond, both personally and collectively. And now, dear listener, our journey through global warming comes to a gentle close, though the larger story continues, written day by by billions of people making choices, by policies enacted, by technologies deployed, by ecosystems adapting. You've traveled with me through 99 facts about one of the defining challenges of our time. You've explored the science of warming, the impacts already unfolding, and the paths forward. Understanding this topic is not about carrying anxiety, but about seeing clearly, responding thoughtfully. Global warming is ultimately a story about systems. Earth systems, energy systems, economic systems, political systems, and how they all connect. It's about recognizing that everything is linked, that actions have consequences that ripple through space and time. But it's also about human capacity for understanding, innovation, and cooperation. As you drift towards sleep now, let this knowledge rest lightly. You don't need to solve anything tonight. Tomorrow you can think about your own choices, your own role, your own voice in the larger conversation. Tonight, simply rest with the understanding that awareness is the first step toward wisdom. Before you fully drift away, if you found value in this peaceful exploration, I invite you to subscribe for more calm journeys through important topics. A like would help others find this space for thoughtful rest, but only if you're still awake enough to remember. If sleep is already pulling you down, that's perfect. The world will still be here tomorrow, still warming, still changing, still full of both challenges and possibilities. People around the world are working on solutions. Engineers and scientists, farmers and forest managers, activists and artists, policymakers, and everyday people making mindful choices. You're part of this larger human family facing this challenge together. Rest well, dear listener. Let your breathing deepen. Let your body release completely into rest. Let your mind settle like sediment drifting down through still water. The facts we've explored tonight will be there if you need them tomorrow. For now, just breathe and rest. Sleep comes now, peaceful and necessary. Tomorrow brings opportunities for awareness, for action, for hope. But tonight brings only rest, only darkness, only the gentle quiet of a mind at peace. Good night, dear listener. May your sleep be deep and your dreams be peaceful. The world awaits your attention tomorrow. Tonight it asks only that you rest. Sweet dreams.